all of these lines right here represent the same vector because they have the same length and they have they point in the same direction. The vector is written as 4, 3. You guys know the slope to be of each of these lines because I just had you guys find them. You know the slope is 3 over 4, right?
Yeah.
And you know the length of all these is 5. Now if we're talking about vectors, we wouldn't say length, we would say magnitude. So I'll put magnitude right here. This vector is a special vector line because it's coming from the origin. It has 2 points. It always has a starting point, which we like to call the initial point. And then it has the ending point, which we like to call the terminal point. Kind of like the word terminal also comes from when we were doing the unit circle. You guys remember having the terminal side? There's the initial side and the terminal side. So this is the beginning point, that's the ending point. Okay, the initial side, initial point, and the terminal point. The ray that is in the standard position, starting at 0, 0, always has its terminal point kind of like equal to. It looks just like the vector in component form. This is the vector in component form. Question. This is, so for this one, that's the initial point, and there's the terminal point. Okay, so there's a starting point and the ending point. All right, so how would I find this vector right here if I was given this point, or these 2 points? Well, this point right here is -5, -9, and this point is -1, -6. Well, what you would do is you would find the slope essentially. To find the first number, you would have to subtract the x's, right? If you want to find the second number, you would have to subtract the y's. Okay, but now here's where the slope is different from the vector. For vectors, you have to do it in this order. You have to do this point first and then this point. Okay, you always have to, because it's different when one of the numbers is negative. Okay, so if I was to try to find the vector, I would say the x would be -1 minus -5. You always do the terminal side first and then the initial. So that's going to be my first number. My second number is going to be the -6, subtract the -9. That'll be my second number, -6 subtract -9. And that's my other number. Okay, so that's going to be adding right there. Okay, that's adding right there. So right here, I would get what? What's -1 plus 5? 4. And right here, what would I get? 3. So there's your vector. You see, it gives you the same vector as what we had before. All right, so let's look at how a problem might look in the textbook that you guys get. This says, find the component form, which is the one with the 2 carets. The component form, let's put little carets right here. The component form and the magnitude of the vector v that has the initial point, there's your starting point, and a terminal point right there. Okay, so my initial point is 4, -7. So I'm going to go, I'm sorry, my terminal point is -1, -5. So v is going to equal -1 minus 4. I subtract the x values first to find the first number, and then -5 minus -7. Now it's very important that I put the terminal numbers first when I subtract, because order matters when you subtract. This is going to equal -5, and that one's going to be 2. So there is the component form of my vector. Okay, that's my answer. Okay, now how do I find the magnitude? The magnitude is the same as length or distance. Okay, and we just did that, which is why we did that. The way you would write that is like this. So that v is my vector. These double lines mean the magnitude. Okay, so it's asking you, what is the distance between the 2 points? To do that, now this is kind of cool, because if I were to graph those 2 points, it would be, let's see, yeah, if I were to graph these 2 points right here, it'd be 1, 2, 3, 4, and then down to negative 7. Oh, I don't have enough space, so I won't do it like that. So it'll be, we'll say that's 4, and that's negative 7. So that was the point right there. And then negative 1, negative 5 would be right about there. Okay. If I look at these, and I draw, a right triangle, my two sides right here, this side, let's use red. This side and this side are found in my vector. Okay, this would be negative 5, and this would be 2. Because it goes back. The vector actually goes like this. This is my initial point, and then there's an arrow that points to my terminal point. Okay, so I don't know if that was confusing. If it was, just ignore it. So all you have to do to find the magnitude is you take the negative 5 and you square it, and you add it to the 2 and square that, and then you square root that. That's how you find the length of it. So that would be 25 plus 4, which equals radical 29, and that's your magnitude.